Hi everyone. So far we've learned 3 methods for solving system of equations, and in this video we're just going to do a quick run through of all 3 methods to make sure we've kind of got them all straight. So you'll notice in the first problem we're going to solve by graphing. The second one will use substitution, and the third one is going to focus on elimination. Now if you also look at each of the systems is going to be the same for all 3 problems. So what we're really trying to show is that there are 3 different ways of solving systems, but they're all going to lead us to the same answer. So let's go ahead first and focus on solving by graphing. Right? We know when we're solving by graphing, sorry, I'm turning the paper here. We're going to look for where the lines intersect. Right, so we're going to graph both lines. I'll turn that back. We're going to graph both lines and look for where they intersect. Now, when I want to graph, I know I want to use slope-intercept form, which is y equals mx plus b. So I'm looking for the y to be on its own. And I notice in both of these equations, I'm going to have to do just a little bit of work to make that happen. So I'm going to underline this first one in blue, and let's look at that first. So my equation is x minus y equals 2, and I know I want y to be by itself. So the first thing I have to do is move over the x, and I'm going to do that by subtracting. So now my x's cancel. I'm not going to forget that negative, so I have negative y equals a negative x, and then I have plus 2. So now y is almost by itself, but I have this negative 1 in front. So to get rid of that, I need to divide everything by a negative 1. So now what's going to happen is I have a positive y. This negative divided by a negative is going to give me a positive x, and my positive 2 divided by negative 1 is going to give me a negative 2. So what that means for me is that my slope is 1, which is just 1 over 1, and my b, or my y-intercept, is negative 2. So we know when we graph, we begin at our y-intercept, which is negative 2. So I'm going to plot that there. My slope is 1 over 1, so I'm going to plot that, and to make this easier to find my solution later, I'm just going to keep that going to the ends kind of my coordinate plane here. And then I forgot my straight edge, so I'm going to use the edge of my packet so I get a nice straight line here. And kind of as carefully as I can, it's a little bit clunky, but I'm going to go ahead and draw my nice straight line. So there's my first line. So now I'm going to use orange here for my second line. So now my equation is x plus y is equal to 4. Again, I have to do a little work to get this by itself, or get the y. I need to subtract x from both sides. So now I have y equals a negative x plus 4. So now what that means for me is my slope is a negative 1 this time, which is negative 1 over 1, and my b is a positive 4. So I'm going to begin at my b. It's a positive 4, so I'm up here. My slope means I'm going to go down 1 to the left 1. And I'm going to continue this until I see pretty clearly there what my intersection point is. So now I'm going to connect my line, or connect my dots, to make my straight line. And now we can pick out that intersection point. Where they cross is this point right here, and I know the ordered pair there is 3, 1. Again, my solution is always an ordered pair, so I write it in parentheses with my x and my y coordinate. So that's graphing. Let's take a look at substitution. Now remember, when we're substituting, it means we want to replace. Right? Substitution means to replace, and we're looking to replace one variable with the other. And the key here for substitution is that one variable has to be alone. So if I look here, I actually don't have an equation where one of the variables is alone, so I'm going to need to make that happen. Now this is pretty nice here because I notice right away the coefficient of x is 1, so this is going to be an easy one to get by itself. So I'm going to take this equation, x minus y is equal to 2, and I'm just going to do some rearranging to make x all by itself. So I'm going to add y to both sides. And then I get x equals y plus 2. So now I can start doing my substitution. I'm going to take what x is equal to, which is y plus 2, and in my other equation, I'm going to replace x with y plus 2. So here's what's going to happen. Instead of x, I'm going to put y plus 2. Then I have plus y is equal to 4. So now I can combine my like terms. I have 2y plus 2 is equal to 4. Let's draw my line here. Subtract 2 from both sides. I get 2y is equal to 2. And if I divide by 2, I'm going to get y is equal to 1. So now that I know what y is equal to, I can take that in either equation and I can replace y. So now I have x minus, well, instead of y, I'm going to put 1, and that's equal to 2. I can add 1 to both sides, and I get x is equal to 3. So now my solution, I know, is an ordered pair. My x coordinate comes first, which is 3. My y coordinate comes second, which is 1. And so you notice our solution is the same as when we did it by graphing. All right, last but not least then, we learned elimination, right? We know for elimination, we need to get rid of one variable. We need one of our variables to cancel out, which means the coefficients have to be opposites. Now in this one, it's actually pretty nice because I notice for y, my coefficient here is a -1 and here it's a +1. So those are already opposites and I can skip right to adding these up. So x plus x is going to give me 2x. A -1 plus 1 gives me 0. If I do 4 plus 2, I get 6. So now I can divide by 2, and I get x is equal to 3. So now I'm going to take that 3 and plug it into my original equation. So instead of x, I have 3 minus y is equal to 2. To solve this for y, I'm going to subtract the 3 from both sides. I get a -y equals a -1. My last step is going to be divide both sides by a -1, and I get y equals a +1. So now again, my answer is an ordered pair. My x coordinate is 3, and my y coordinate is a +1. So again, that's just a quick review of all three methods for solving systems of equations. When we're back in class tomorrow, you'll work on a review, and then we'll be getting ready for a quiz when we're back after the long weekend. All right, see you back in class.